Hello, we are in F3. We will have 6 videos for this section, so we have a lot to talk about here. So we're going to just jump right into F.3 lines. We're going to begin with calculating and interpreting the slope of a line. So let P be x1, y1 and Q be x2, y2. These are just two arbitrary points on a line. Where x1 does not equal x2, the slope M of a non-vertical line L containing P and Q are defined by the following formulas. M equals y2 minus y1 over x2 minus x1, but recall x1 does not equal x2. So the reason that we don't want x1 to be x2 is because if we did that, that would be 0, and we cannot divide by 0, and they address that the following sentence. If x1, x2, L is a vertical line and the slope M of L is undefined, since this results in division by 0 because we cannot divide by 0. So if you look at the line that's given here, that is slanting left or right. If you make that a vertical line, then that line ends up being a slope that is undefined. So a lot of people get confused with what's vertical and what's horizontal, and we'll discuss that as we progress. So if you look at the line that's below here, they identify the distance that you rise. That's the vertical distance. That's y2 minus y1. The horizontal distance is x2 minus x1. So the slope is given by y2 minus y1 over x2 minus x1. We call that the rise over the run. And we have other names for it too as well. We have the change in y or the change in x. So the change in y is equivalent to saying the rise. The change of x is equivalent to saying run. Or we just simply say in mathematics, the change in y over the change of x is delta y divided by delta x. Those little triangles refer to deltas. And it means change. If it's a vertical line, slope is undefined. L is a vertical line. So if you notice the x coordinates are the same. And when you subtract them in the denominator, that will be 0. You cannot divide by 0. So all vertical lines have an undefined slope. Any 2 points on a line can be used to compute the line of a slope. So you're not just stuck with 2 points. You can use any 2 points that you would like. Since any 2 distinct points can be used to compute the slope of a line, the average rate of change of a line is always the same number. So whether you use the points that are in the second and third quadrant, A and B, or if you use the P and Q, they will give you the same thing because it's constant. All graphs don't have that characteristic, but lines do. The slope of a line may be computed from P, x1, y1, and Q, which is x2, y2, because whether you're subtracting one way or the other, the one side will be maybe positive, but when you take the reflection on both sides, the bottom and the top, then they're both negatives or opposites of each other, and they cancel out anyway. So it really wouldn't matter which way you go with that. You just have to be consistent. So we have 2 different ways to say the formula. And on this example, we're going to find the slope of arbitrary 2 points, -1, 4, and 2 and -3, which makes up 2 points on a particular line. If we do it using the first formula, look what happens. We've got -3 minus 4. We're using the second y coordinate minus the first y coordinate divided by the second x coordinate minus the first x coordinate. And you might say, well, I thought that was supposed to be minus 2 plus 1. Well, it's 2 take away -1. The abscissa on that first point is -1. So 2 take away a negative is 2 plus. That's the reason it's plus down there. And so if you do the math, it's -7/3. However, if you do it the other way, you'll go 4 take away -3, which makes it 4 plus 3. And then the first x coordinate is -1 minus the second x coordinate is 2. So it's -1 minus 2. And if you do the math, it turns out -7/3. So this kind of shows you that it doesn't matter the order that you subtract them, one way or the other. You don't have to do both. You just got to pick a way and be consistent about it. So the average rate of change of y, which is in line terminology, that's called slope, is -7/3. We also talk about average rate of change later on in the semester when we're dealing with graphs that are not lines. So that word you might want to keep in your head. Okay, next example. Find the slopes of various lines containing the point 2, 3. So the 0.23, and then we're going to give you 4 different points to go with. -1, -2, 3, -1, 5, 3, and 2, 5. So using the formulas, the hot pink one, the first line, is -2 minus 3 over -1 minus 2, which is 5/3 it turns out to be. The second line, line 2, using the same example, it's going to be -4. The third line, the blue one, is going to be 0. Well, the reason it's 0 is because the y coordinates are the same. 3 minus 3 over 5 minus 2, 0 divided by 3 is 0. And then the last line we discussed before, if the abscissas are the same, it's going to be undefined. But if you do the math like you did the rest of them, you'd go 5 minus 3 over 2 minus 2. Yeah, of course, 5 minus 3 is 2, but the problem is 2 minus 2 on the bottom turns out to be 0, and you cannot divide by 0, and that makes the line undefined. So they give you 4 different lines, and they're going to graph them here. The hot pink line is a positive slope. The orange line was a -4. The blue line was 0, and the green line has undefined slope, and it's a vertical line. And what you're seeing here, it happens all the time. If you have a positive slope, like the 5/3, all positive slopes is going to go up left to right like that hot pink one does. The orange one, -4, yes, has a negative slope. So all the slopes that are negative will go down like that one, left to right, as that one does. Third line, the slope that's 0, the blue one, it's a horizontal line. All horizontal lines have 0 slope, and all 0 slopes will have horizontal lines. Vertical line, that green one, is undefined slope. So all vertical lines have undefined slope, and all slopes that are undefined are vertical lines. And I summarize it right here. Positive slope, it goes up from left to right. Negative slopes go down from left to right. Slopes that are 0 are horizontal, and when slope is undefined, it's vertical. All right, seeing the concept. So what we're going to do is we're going to graph all of these on the same screen, but we're going to do it a little faster. We're going to do it on the computer screen right here. And so if y1 equals 0, if that's the first one, and if you notice, that's basically the x-axis. It's horizontal. y2 is -1/4 x, so it's slanted downward. y2 is slanted downward because it has a negative slope. But look at the next one, -1/2. It's slanted even more. -1x slanted even more. -2x slanted even more. -6x of those is the most one that's most slanted at all. So as the magnitude of the slope increases, the line becomes steeper. So if you notice, -2x is not as steep as -6x. -1/4 x is not as steep as -1/2 x. So it's the magnitude. The negative just tells me it's going down, but the number itself is to tell me how steep it's going to be. The bigger the number, the steeper it is. Alrighty, our next video that we'll be doing in a minute would be called the graphing lines over the point and of a point and the slope. So that will be our second of our 6 videos. But this concludes our first video. And again, as always, if you have any questions, please contact me. Have a good day.